Today we are going to pick the discussion from the book called Business Statistics Using Excel, SPSS and R. And it is coming from Cengage publication. Wonderful book it is. And what I have done, I have pinned up some of the discussion which we are going to discuss today. And let's see the first one and what the chapter and all that and so on. There is a brief content been given here, and there are totally 10 chapter in it. Each chapter been beautifully been described. One, let the begin the number journey, and there it talks about the statistical differences and what is mean by inferential statistic and descriptive statistic. Then it goes to next one, how to make the number visually appealing. Some of the pivot table charts and all that being discussed. And number dissection, knowing the center point, measure of central tendency, when to use mean, median, very beautifully been illustrated. We're going to take a discussion from there. And where the number are moving to, right? Knowing the strength and balance, measure of dispersion, association, shape, everything. And the art of being tentative. Here, all the probability basis and probability distribution like binomial, normal distribution, then you have Poisson distribution, Gaussian distribution, all that being discussed. How much is too much? Understanding the sampling method, and there is a discussion about stratified sampling and multi-sampling and so on. The world of approximation and possibility. There is this the extent of the previous chapter being discussed here. Mainly it talks about the hypothesis testing, and then you have dare to differ, non-parametric tests. So what is the non-parametric test and all that? And then the ninth chapter is that let us do some experiment using ANOVA, analysis of variance, and then love to predict the question mark, simple and multiple linear regression. You also have a statistic tables and bibliography and index and so on. This is the one. And then furthermore, if you go, you have a detailed content to each of the chapter. 8 of the 10 chapter, you have a detailed content to it where it talks about a little bit more granular detail and so on and so forth. And let's go. And the first one, it talks about two things. One is called descriptive statistic. One is called inferential statistic. What the difference between these two? Wonderfully being discussed here. If you look at the descriptive statistic, describing the data or phenomena from the number, right? Inferential is that you take the sample and draw the population conclusion of a population, right? And the population sample are drawn from the population and so on, right? That's the basic definition, but here it has given more neatly here. So it is descriptive statistic. It is describing the target population. Whenever we are talking about descriptive, we are only talking about population. It can be quickly done by creating the chart, graph, organizing the data, like sorting the data, all that. The data is organized, analyzed, and presented. They describe the available data effectively. And the commonly used statistical tools are mean, median, mode, standard deviation, variance, range, all that, right? So this is all descriptive statistic. On the other side, you have inferential statistic. It is about drawing the inferences from the sample and generalizing them to the population, right? You take the sample and then you're equating or generalizing to population. The outcome come in some probabilities and sources and particularly drawn through the some formulated hypothesis. Like you have a chi-square and then you have a ANOVA, one sample two test, two test sample t test and all that. Here the data is compared, tested and predicted. It concludes the population which is beyond the availability and infer the result. The commonly used statistical tools are hypothesis testing, like it has given an example of ANOVA, but you have various other examples like one sample t-test, two sample t-test, ANOVA, chi-square, one proportion test, two proportion test, Mann-Whitney, and all the other things you have, even the median also. This is what The first it talks about it. Furthermore, now we are going to the next one, how to download R software. And I don't know about R. I'm gonna learn from this book, and I already planning to download this and then try to use it. So there will be a discussion about R also in coming up your way. And then it has also given a little bit detail how to download and so on. And then each chapter has got test your skills and so on. They can see here. And then we are moving to, so we discuss about three. Now we are moving to fourth. Fourth, actually, like here, the frequency formula, and sometimes it doesn't pick up the count properly, right? So all you have to give is that shift control enter, right? Whenever you complete the formula, and you have to give shift control enter. And here it is given that. So that will add that curly bracket before that command will add the curly bracket before the equal to and after the equal to. With that expression, you can easily calculate. For example, let's say you have this data. For that, you wanted to calculate the frequency. You will not be able to do that, and then you can directly pick from this control, shift, and enter commands. And then we are moving to the fifth one, and my favorite, that is a lot of details been given here. So there is a difference between mean and median. Wonderful been constructed. For example, mean, advantage and disadvantage. Mean, it takes account the data to calculate the average. Straightforward, anytime when you wanted to calculate whether it's a discrete or continuous, you can easily calculate. The median is not affect. I mean, this is what, and the disadvantage of the mean is that if the data affected with the compare extreme value, so you have a bell curve which is extremely skewed or left is skewed, extremely left is skewed, then you cannot rely upon mean, right? And they give a lot of example, right? For example, the average lifespan in US is 70, right? So 70 is just an average, but actually some may live greater than 70, some may live less than 70 and all that, right? So when the data differs too much, you have to take the median. That's what it talks about it. And the median is not affected by extreme value. Even if you have outlier or extreme value, it doesn't affect. So that's an ideal way in which there's the advantage of median. And median is the positional average. Therefore, arranging the data in order of magnitude, either ascending and descending, and it's a time consuming that we have to sort the data and do that. Now, all Excel, all the software, you can easily do that. And mode is something repeated value and all that. So that is the case is being given. And then real life situation also, where to use mean, median, mode also given. So there is given that mean revenue earn per advertisement, and the revenue in general we can add it. Median, the marketers can also calculate the median revenue earned per advertisement to gauge how well the advertisement perform and reflect upon the advertisement performed better than the median, less to the than the median assess. So precisely locating, identifying the proper position 50-50, then you can use that median asset. And then there is a discussion about weighted mean or weighted average, how to calculate. So the formula is very, very straightforward. Summation of W and X. W is the weighted factor. Let's say you have 5 factor, and then you can take this one. I mean, here they have given 3 factor, and you can easily calculate. And then you have X is the mean value. So, and then there is other thing called harmonic mean and moving average, and all that is going to come up next. And then there is a calculation about that, how to calculate this one. For example, let's say, I think the very example I can pick it up from example number 4. And there are 3 factor. Assignment should be 20% marks, and project is 40%, term and examination is 40%, right? Let's say if we get that assignment 35, right, out of 40, and the project 40 out of 40, and then you have other score is 36. Like how we can calculate? So all the weight you can put it down, 20, 40 and 40 in the denominator, and then each factor you can multiply with the weighted mean. For example, 20 times 35% and 40 into 40, 40 into 36, you can get that value. That means 37.4. That's called weighted average. Okay, let's go to the next one. And then here it talks about, as I said, that in the mean itself, we have a geomean, harmonic mean, and so on. And then there is a quartile, percentile, all that it has given. And then using SPSS also, it has given a little bit more detail also as well. Okay. And then the very famously one, the empirical rule, right? So that has been given here, the 78, 75 percentage, 88 and 93. And then the same thing, empirical rule. This is given from, okay, 68, sorry, 68 percentage, 95, 99.73. And then there is a movement and then left is skewed, symmetrical, right is skewed, and kurtosis all they've been discussed here. And by model also been discussed further. Okay, let's go to the next one. And then we are going to, in the school, we have studied this one, Venn diagram, right? So Venn diagram is also been given how it can be applied in a business context, where there is union and intersection and disjoint, how we can use it also as well. And then there is a permutation and combination also being explained here. You can see a permutation and combination is connected to Venn diagram. Okay. And then you have that how to apply the formula. For example, let's say if you wanted to find out what I like about this book is that at the end of the chapter, you have all the formula in Excel. I mean, and also the Excel formula and theoretical formula also there. For example, binomial, Poisson, Z, how it is calculated, x minus mu divided by standard deviation, right? The same you can apply using the standardized formula, right? If you do that standardized formula, you can directly apply here. So same like binomial distributions, you can find it here, and Poisson distribution you can find here. And if you want Z square, you can Z value, you can find using standardized also as well. And now we are moving to the next one is called sampling. In sampling, there are many sampling, right? So stratified sampling is there, cluster sampling is there, and you have a systematic sampling, multiple sampling and all that. About that, it has given little detail also as well. And then I really like that when you say sampling, how much is too much, right? That's what the funny title it has given, but it is a very, very good to easy and easily we can identify and understand that. And then furthermore, it has given little central limit theorem plays a major role. Why we need the 30 data, and if these 30 data is there, the standard error of mean will get reduced. All that little bit of definitions and all that has been given there. And each chapter you will have the differences, stratified sampling versus cluster sampling, what is advantage and disadvantage and all that. Okay, let's go to the next one. Level of significance, right? We call it the alpha level of significance that is also been given here. In English, signifies mean importance or essential, right? However, in statistic, signifies mean probably true. And when a statistician says that the result is highly significant, which means it is perhaps true and not the result to be significant. So then there is a discussion about one tail test, two tail test and all that. One tail mean we are using one tail 5%, let's say significant value is 5%, and two tail mean you are distributing both the side 2.5, 2.5%. Okay, then there is a discussion about hypothesis, how we can use a hypothesis and all that. And then you have furthermore how we can use that hypothesis value and calculate in Excel and using the simple formula and all. Okay, there you go. And then largely now in this chapter, there is a big discussion about analyze tool pack, how we can use the analyze tool pack and so on, and Ztest and how we can use the Ztest and whether it's significant. You can see that the value is significant because the p-value is less than 0.05. And furthermore, t-test has been given and all that, right? So various other chapters been given here. And then there is a non-parametric test is there. And also I really like the quotation they've given about briefing they have given about the non-parametric test. You must be curious to know if there is anything that doesn't follow the normal distribution, right? So we say always 68, 95, 99.73, that empirical rule, that bell curve. Is there anything which doesn't follow that? As a statistician, will be interested in knowing about them. Yes, something do not follow the normal distribution. A statistician love to explore such data, and this is what the non-parametric tests come into play. And you have chi-square is one of the many non-parametric tests. Other non-parametric tests includes the correlation, Spearman rank correlation, Mann-Whitney, Kruskal values, Friedman test, and many more, right? So this is what it has given here. Chi-square, there is a great discussion. The chapter we are discussing is dare to differ, and then we can just see after 2 pages. And then whenever you say talk about the chi-square, we are talking about expected value. From the actual value, we can just differentiate and get that value. Summation of O minus O is original value minus E is expected value, whole square divided by E. And then you can do it in Excel also. How to do it in Excel, that is also been given here. And then Mann-Whitney test, that's what we are going to do. Non-parametric test, one of the things is that you rely upon median, and you can compare and all that we can see. This popular non-parametric test compares the outcome between two independent groups. The Mann-Whitney is also called Wilcoxon rank method. And whenever you want, we can just have the same assumption. The population is hypothesis, null hypothesis, alternate hypothesis, we can. Okay, so now we are moving to the next one. And then ANOVA, let's do some experiment. ANOVA, it has given a little bit more detail actually. ANOVA, why it is ANOVA is required, and so on and so forth. And ANOVA is a parametric test because ANOVA depends on the continuous data. So parametric test. ANOVA helps to understand how the different group respond with the null hypothesis with the test that mean of the different group are equal or not equal. Like we can test it and all that. So okay, there is something called randomized design, TRD, that is also been given here. And then, so largely how you can do it in Excel analyst tool pack, that is also been given here. And I'll show you one more page also. The same thing which can be done in using R and SPSS also as well. Okay, so what I wanted to also say is that some of the data set, for example, this is a salary data set, and you can download all these using this one, right? So there is a barcode been given. From the barcode, you can use it in mobile and you can use it in laptop also. You'll be able to download and then practice that also as well. That's something is interesting, and we will explore some of the data set what has been given here. In the upcoming video, we can find that detail also as well. So let's go to the next chapter. We were discussing this chapter now. So ANOVA we were discussing, and then now we are talking about regression. And regression, I will try to explore that data set, and then we can discuss the answers in detail. Of course, the multi-regression been given here, and how to do it in SPSS has also been given here, and all that, right? So that's it on this. So before we wrap up, so let's do a quick one. This is the books being used to make this book. So a lot of wonderful books the reference been taken from wonderful books. Okay, let's do that quick summary now. So what I did, so it is, since it is coming as alphabetic, it is very easy for me to quickly give you that one. A for arithmetic mean, right? So mean, average, right? You have weighted average, you have a geometric and harmonic and all that we discussed. B, Bayes theorem, right? So you take the new information and rely upon, right? Then binomial distribution, we talked about it, how to do it in binomial distribution. So whenever you have that attribute data, you can use the binomial distribution. Chi-square is a non-parametric test. You need to have that expected value and all that we discuss about. Coefficient of variation is always referred in percentage that we talked about. And then that is for C for chi-square, we talked about coefficient of variation. And now we'll talk about D is data measurement and all that. And then descriptive statistic, we differentiate in the beginning, we differentiate descriptive statistic versus inferential statistic. Then we learn that in E for empirical rule that we discuss, and then you have expected value also we discuss, that is required for chi-square. And then frequency, that how to apply the formula, the the curly curve that we discuss about it, curly bracket we discuss about it. And then we have discussed about G for geometric mean and harmonic mean and all that. H for histogram bell curve we talked about it. Hypothesis we talked about null hypothesis and alternate hypothesis. I for independent inferential statistic that we talked about, normal distribution, n for normal distribution. O for ordinal data, p value, significant value, whether it's due to chance or significant value, or it has a significance that we talked about. Poisson distribution we talked about it. Probability we talked about it, and Q for quartile, and in the box plot you get the quartile. And randomized block design we talked about that also, as well as part of ANOVA we talked about. Regression we talked about, multi-regression and this regression. And then S for standard deviation, that is a part of the main descriptive statistics that we talked about it. And then T for and T distributions, you have on that we talked about it. And two-way ANOVA, and U for union, intersection, and all that we talked about it. And then we have Venn diagram. As part of the Venn diagram, we talked about that one also as well. And V for variance also we talked about it. And W for weighted mean, and Wilcoxon sign method, and Z for Ztest. So a lot of things we talked about. I hope this you find this one very useful. All the business key terms of business statistic being discussed in this video. Please stay till the end. You will find a lot many information, and I will also will explore the data set, and one more thing that I'm going to learn SPSS and R software also as well. And please stay tuned. Have a great day ahead. Thank you so much.